Cloud data center. In the last section, we discussed from a theoretical perspective what constitutes a data center. In this section, I would like to give you a tour of some of the aspects of the data center. As a cloud professional, it's a good idea to know what a data center looks like, how it's built, how it's organized and operated. If you've not visited one, it would be a good idea if you can ask someone to take you to a data center. Fortunately, in my career as an IT professional, I have visited several data centers, but unfortunately, due to security reasons, I cannot show you the ones that I visited. But fortunately, there are several videos from many organizations and companies that want to showcase their products and services and the data centers, and so they have posted several videos online. In this section, I've pulled a collection of many of these videos so I can show you those videos so you have a better understanding and appreciation of the makeup of a data center. So as part of this section, we'll look at a video on how a server rack is organized. Then we will look at how cabling is done across server racks. Then we'll look at the top of a rack switch. This is a company that is advertising top of rack switch versus the end of row switches that we talked about. Then we'll look at cooling. We know that cooling is a very important aspect of a data center because IT equipment generate a lot of heat. Then we will look at airflow from the perforator floor. Then we'll look at a mechanical room, and then we'll look at a containerized data center. It's a company that is showcasing their container data centers. Then we'll look at data center stuff, which is a very important part of data centers. Then we'll look at the Google data center. Google has uploaded their video on what their data center looks like. So it's one of their several data centers. So let's look at that. And then we'll look at the Microsoft Cloud data center. All right, let's begin. In this video, you'll see how server racks and cabinets are built so that the servers can be arranged from top to bottom in an organized fashion with appropriate ventilation and space for wiring. This is a video from a company that is selling server racks featuring a specific model. So let's take a look at this.
Hey guys, welcome back to Global One Server Racks. Today we're going to go over the APC AR3300 SX enclosure. This cabinet comes with a locking mesh front door. Each cabinet comes with a perforated rooftop along with adjustable square hole mounting posts. As you see numbered here, up to 42U in space. Each cabinet also comes with sectional side panels. You have a top and a bottom panel. Easy to remove. It's a single push button, as you see here on the bottom panel. These cabinets also come with perforated rear doors. Each door is a split rear door design. Comes with a single swing handle. We do provide keys with each enclosure. Here you will see the additional PDU cable management mounting space. Each one of these cabinets offer this on the left and the right side. These cabinets are available online at globaloneresources.com. You can also reach us toll free, 877-307-7225. We thank you guys for taking your time to look. Come back and see us.
That was a video on server rack. Well, a data center has many of these racks connected, and then you have to run wiring through these different racks. We talked about structured and unstructured wiring. In this video, you will see how facilities professionals are laying down racks and the cabling system to connect the various servers. The servers are not there yet, but they are laying down the cables anyway. So take a look at how cables are laid out in a data center.
2 hours later. Two hours later. Two hours later.
That was a fun video on laying cables. We also talked about switches. We talked about two kinds of switches, top of rack switch and an end of row switch. In this video, you will see Netgear advertising its top of rack switch.
A top of rack or TOR switch is a switch that sits at the very top or in the middle of a 19-inch rack in data centers or server rooms. Each server and network storage device can be directly connected to the TOR switch, eliminating the need for intermediate patch panels. The only cabling outside the rack is the TOR switch uplink connection to the aggregation layer, making moving racks easy. XSM7224S provides a stackable 10 gigabit Ethernet switching solution, enabling cost-effective SAN connectivity for servers and network storage. Distributed LACP functionality provides better availability and redundancy for servers and storage, in addition to better performance. Also, active-active server teaming can be distributed across two stacked switches, ensuring physical redundancy for the server while it is connected to the same logical switch. LACP support also provides failover protection if one physical link goes down, while iSCSI traffic load balancing ensures greater transmission throughput with lower latency. With hot swap dual power supplies, front-to-back air cooling, and two replaceable fan trays, XSM7224S is compliant with data center availability standards, and distributed LACP allows for active-active server teaming to easily deploy resilient virtualization. Buy the Netgear ProSafe 10 gigabit stackable L2 Plus managed switch and experience the versatility of 10 gigabit deployments. Netgear. Connect with innovation.
In a data center, IT equipment generates a lot of heat, which means you have to have cooling to keep the temperature within the data center in check. Otherwise, you can have equipment failure. In this video, SoftLayer, an IBM company, discusses cooling for a cloud data center.
We're in D5 Pod 1 in Dallas in our Alpha headquarters, and I wanted to quickly show you how the AC units work in our data centers. A couple people have asked on Twitter what that looks like, and I have no idea if you can hear me, so I might be yelling and you might be having to kind of turn down your volume. So what we got on the edge of the room here are the crack units, and so these are the computer room air conditioners, and the way that they work is each one of them will pull air from the top of the top of the room, and then it'll condition the air, it'll push it down underneath the floor. And so from the top of the room down to the floor, it goes into the cold aisles in our data center. So this is one of the cold aisles in the data center, and it's a cold aisle because all of these servers will face in toward it, and you'll look down on the floor, and there are kind of perforated tiles. And these tiles allow for the cold air from underneath the floor to go up in front of the servers and then get pulled into the front of the servers, and that's what actually cools the servers as they continue to go. The most important temperature in the data center is not on the other side of the servers in the hot aisle, it's actually at the top of the cold aisle, like the highest server in the cold aisle, because you want to maintain a good temperature for each one of the servers, and the hottest temperature in the cold aisle is going to be at the top of that, at the top of the rack. So we can actually go over to the other side, and you can see as the air comes up through the floor, it's going to go into the servers in the front and then be exhausted in the back. So here you'll see it's a lot warmer over here, and all the cold air is getting pushed through the server and warmed up because it's going over all the components and being exhausted out here. And because warm air rises, it's going to continue to go up into the room, and from there it's going to just move back over to the crack units. And you see that on the top of the crack units there are these plenums, and the goal of the plenum is to get as high in the room as possible so that you get the hottest air. You don't want to get air from right here because it's going to be cooler than air from up there. So you want to do the most efficient cooling by getting the hottest air and then just processing. So that's how computer room air conditioners work.
If you recall, we talked about the hot aisle and the cold aisle. So as you see in this video, he talked about the two different aisles. Cold aisle is where the perforated floors are pushing cool air from the bottom up, and the hot aisle is where the heat is rising up and the hot air is rising to the roof. This is a fun little video. This video shows you how a perforated floor, in fact a perforated raised floor, pushes cold air from the bottom. So you have a small post-it paper that is floating or hovering over the floor, being pushed up, illustrating to you that the cold air is being pushed from the bottom to the roof. That was fun. All right. Now let's look at the power mechanical room. We learned that every data center has a mechanical room, which is where they have the cooling equipment. In this video, you will see a product team lead from Bell Hosting talk about the mechanical room and how they have teamed up with local companies for power.
Hi, I'm Danny Galore, Product Team Lead for Bell Hosting, and we're here in one of our new data centers. And we just wanted to talk about some of the key features that this data center has, specifically to do with the mechanical room that we're in. As you can see, the mechanical room that we're in right now is a very clean environment. There's a good reason for that. What we've done here is we've partnered up with a local community power provider, and what they're going to be able to provide us with is both power and cooling capability for our data center. Now, the way that they're providing power is in three different ways. The first way is that they're providing power from the grid. The second way that they're providing power is directly from power generators that they're continuously turning on, and therefore do not require the need for continuous testing of the generators. The third way that we're getting power into this data center is through a solar array that's sitting on the roof, and on a nice sunny day, that provides a significant part of our data center power needs. Now, the other part of what the provider is giving us is chilled water. And the nice thing about that is that the chilled water is actually capturing the heat from our data center and reutilizing that heat within the local community. We're able to heat schools, we're able to heat swimming pools, and we're able to heat community centers. Another good story. As you can see, what we've done here is we've created a situation where the power provider is actually able to concentrate on what they do best, which is providing power and chilled water to an environment. And we can concentrate on what we do best, which is taking care of your data in a secure fashion. As you can see, Bell is building data centers right now that are able to help the environment in a very efficient and very green manner. And this creates a situation where we've got a win for our customers, a win for our data centers, and a win for the community.
That was an example of an eco-friendly data center design. Okay, so now let's move to the containerized data centers. If you recall, we talked about data centers that are built based upon container technologies that look like shipping equipments. And these container data centers have everything in it. They have the servers, they have the power, they have the cooling, the mechanical, everything that you need is within a container. And you can actually take many of these containers together to build a larger data center. So let's take a look at a containerized data center. It's actually an ad from a company called Green Data Systems.
Containerized data centers from Green Data Systems and powered by Hitachi Data Systems. The most compelling and useful option for data centers are containers. This is because of their modular nature and their ability to be located anywhere. Today, we would like to introduce you to containerized data centers from Green Data Systems and powered by Hitachi Data Systems. Containerized data center solutions provide a sustainable, fast, and flexible way to expand, complement, or even replace traditional fixed brick-and-mortar data centers. The modular approach that Green Data Systems has developed adds capacity as needed and is more manageable and cost-effective. It reduces capital expenditure and provides a potential 80% saving in operating expenses. Realization of a conventional data center usually takes 24 to 36 months. Green Data Systems containerized decanters can be implemented within 10 weeks and can be customized with quality cooling, security, UPS, and IT technology. Green Data Systems containerized data centers are smart solutions for rapid, easy deployment of high-density computing and can be shipped to customer sites throughout Europe. Containerized data centers are the flexible answer for current data center requirements, powered by Hitachi Data Systems.
Now let's take a look at a video on data center staff. A key success to data center operations is its staff. In this video, a company that provides managed staff services for data centers talks about the capabilities of the staff to man your data center.
We have our own electricians on staff, we have our own engineers. All of our electricians can handle any problem that occurs. Most other facilities do not have these people on staff. We monitor the electricity, we monitor the electric utility. We are able to control and see what's going on 24/7. We're making sure that the power and HVAC is always running properly.
I have a friend that works for Google, so I visited the Google campus. But unfortunately, I could not see much of the data center because of secrecy and privacy within Google. But this video from Google gives you a tour of the Google data center. Take a look at this video from YouTube.
A data center is the brains of the internet.
The engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row of machines, all working together to provide the services that make Google function.
I love building and operating data centers.
I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
In layman's terms, what do I do here?
I typically refer to myself as the herder of cats.
And I'm an engineer, hardware site operations.
We keep the lights on, and we enjoy doing it.
And they work very hard. So we like to provide them a fun environment where they can also play hard as well.
We just went past the 3 million man-hour mark for zero lost time incidents. 3 million man-hours is a really long time, and with the number of people that we have on site, that is an amazing accomplishment.
I think the Google data centers really can offer a level of security that almost no other company can match. We have a information security team that is truly second to none. You have the expression, they wrote the book on that. Well, there are many of our information security team members that have really written the books on best practices in information security. Protecting the security and the privacy of our users' information is our foremost design criteria. We use various layers of higher level security the closer into the center of the campus you get. So just to enter this campus, my badge had to be on a pre-authorized access list. Then to come into the building, that was another level of security. To get into the secure corridor, which leads to the data center, that's a higher level of security. And the data center and the networking rooms are the highest level of security. And the technologies we use are different. Like for instance, in our highest level areas, we even use underfloor intrusion detection via laser beams. So I'm going to demonstrate going into the secure corridor now. One, I have to be on the authorized list with my badge. And then two, I use a biometric iris scanner to verify that it truly is me. Okay, here we are on the data center floor. The first thing that I notice is that it's a little warm in here. It's about 80 degrees Fahrenheit. Google runs our data centers warmer than most because it helps with the efficiency. You'll notice that we have overhead power distribution. Coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server rack. These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. It's true that sometimes drives fail and we have to replace them to upgrade them because maybe they're just no longer efficient to run. We have a very thorough end-to-end chain of custody process for managing those drives from the time that they're checked out to the server till they're brought to an ultra-secure cage where they're erased and crushed if necessary. So any drive that can't be verified as 100% clean, we crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this. In the time that I've been at Google for almost 6.5 years now, we have changed our cooling technologies at least 5 times. Most data centers have air conditioning units along the perimeter walls that force cold air under the floor that then raises up in front of the servers and cools the servers. In our solution, we take the server racks and we butt it right up against our air conditioning unit. We just use cool water flowing through those copper coils that you see there. So the hot air from the servers is contained in that hot aisle. It raises up, passes across those coils, where the heat from the air transfers to the water in those coils, and then that warm water is then brought outside the data center to our cooling plant, where it is cooled down through our cooling towers and returned back to the data center, and that process just repeats over and over again. To me, the thing that amazes me about Google and the data centers is the pace of innovation and always challenging the way we're doing things. So when people say that innovation in a certain area is done, that we've kind of reached the pinnacle of what can be achieved, I just laugh.
Now that was Google, the Google data center. Google is a pretty big company. The last time I heard, they have close to 1 million plus servers. And so they have very specialized data centers, very customized data centers. You saw their server racks are very specialized. You also saw the cooling is also very specialized. Since they are operating at such high volumes, they have devised their own technologies for the data centers. Okay, now let's look at one more video. We're going to look at the Microsoft data center, which is going to talk about the Microsoft cloud technology. Don't forget, Microsoft also offers a cloud platform called Azure. So in this video, Microsoft talks about their cloud data center. Let's take a look.
Microsoft's cloud is comprised of a globally distributed data center infrastructure supporting over 200 online services, including Azure, Office 365, Bing, MSN, Windows Live, Hotmail, and Xbox Live. More than 1 billion customers and 20 million businesses in over 70 countries use these services each year. Today, we're going to take you on a brief tour of a Microsoft data center and share how we ensure trustworthy and reliable cloud services while continuously improving performance, scalability, and efficiency. Microsoft operates a global array of data centers and edge compute nodes, all connected through a high-speed network. Our major data centers house tens of thousands of high-performance processing and storage servers in high-density racks. Chillers and air handling equipment ensure precise control over environmental conditions. Uninterruptible power supplies, or UPS systems, and vast banks of batteries help ensure power remains continuous in the event of a short-term disruption. Emergency generators provide backup power for extended outages and for planned maintenance, and can operate the data center with on-site fuel reserves in the event of a natural disaster. A high-speed, robust fiber optic network connects servers within the data center and connects each data center with other major hubs and internet users. Edge compute nodes host workloads closer to the end users to reduce latency and increase overall service resiliency. Microsoft ensures high availability through multiple layers of redundancy, advanced monitoring and incident response, and geo-redundant backup and graceful failover capability, all managed through our geographically distributed Microsoft Operations Centers operating 24/7, 365 days a year. We also deploy one of the largest implementations of Microsoft System Center in the world, and we use our own data repository called Scry to record power consumption and allow precise cost allocation to our internal business groups. Power Usage Effectiveness, or PUE, is the measure of total data center power consumption divided by IT, or critical power, and highlights how much power is consumed by supporting infrastructure versus the power to operate servers. A typical industry data center has a PUE of approximately 2.0, where the amount of energy consumed for the facilities and supporting infrastructure equals the energy to power the servers. Our latest modular data centers have reduced PUE significantly, typically in the range of 1.15 to 1.25. PUE is a useful metric, though we look holistically at all components of the data center and optimize for performance per watt consumed in total. Our modular approach to data center designs helps us rapidly scale to meet new customer demand, and our innovative use of free air cooling helps improve efficiency and sustainability. Security at our data centers employs outer and inner perimeters with increasing security at each level, utilizing a combination of technology and traditional physical measures. We maintain hundreds of controls across multiple levels of operations. At the data centers, technical security elements include two-factor access control, badge readers, extensive camera monitoring, and integrated alarm systems. Traditional measures can include perimeter fencing, security officers, and locked server racks. Data secured in Microsoft's data centers is classified based on its sensitivity and protected accordingly. In addition to maintaining best-in-class operations processes, we routinely bring in third parties to verify our capabilities, resulting in ISO 27001 and PCI certifications, SAS 70 Type 2 or SSAE 16 attestations, and FISMA certification. Microsoft's award-winning cloud infrastructure powers the cloud services our customers and partners use every day and delivers these services with trust, reliability, performance, and efficiency.
That was the Microsoft data center. It's interesting how both Google and Microsoft talk about security. Security is a very, very important aspect of a data center, especially a very important aspect of cloud computing. We have an entire module devoted to security. In fact, you might even take there is enough material on security that you may even take an entire course on cloud security in the future. In summary, we saw several videos. We saw a video on what a server rack looks like. We also saw a video on how cabling is done across racks. We saw the top of rack switch, cooling and airflow in data centers. We also looked at the power mechanical room. We also looked at modern containerized data center and how they can be put together to build a larger data center. Then we looked at data center staff, which is a very important part of data centers. Then we looked at two data centers, Google data center and Microsoft data center, and how they talked about how important security is within their data center. So the next time when you go to your infrastructure team and ask for a server, or now with cloud computing, you will be able to just ask for a server through some kind of a console. The next time you do that, just think about all the complexities, all the things that are happening behind the scenes for you in terms of hardware, in terms of equipment, in terms of the infrastructure that is making it possible for you to get a machine, a server for your computing.